So, okay. Uh, yes, we are here, and this is, we can start now. Yes, I think.
Yep, great.
Okay. Um, okay, if you are hearing me, we have no problems. We start now. Um, uh, we are talking today about patterns, about the topic of our presentation today. This is my name. I am Nicolas Arias Velandia. Now I am part of the Department of Early Childhood Education as doctoral student in Early Childhood Education. And I made part also for the Center of Excellence in STEM Education at East Tennessee State University. In that uh, unit, we are developing a research project and a kind of service project also called Libraries Count that is about early math in libraries and community and the community settings. They have an invitation as we are having them here. Because if some of you work in libraries or have people who work in libraries and want to join, we have a professional program that is online and can join and can give us some feedback. This is the information there. And the presentation that we are making today is based in the part of patterns that we did for that Libraries Count project. This project is a 3-year funded project by the IMLS institution. And is about the co-creation of online professional learning program for library staff focused on early math with diverse family and their children. And this is the co-creation is because the participants are giving feedback and we are creating with them all the content in different moments. This is what is that about? It is developed in this moment in 10 different states in United States. Like you can see California, Arizona, Colorado, Tennessee, Alabama, Rhode Island, Massachusetts, New York, Maine, among others. If you are in one of those states, or the people who is interested can participate. Um, this is the where that idea uh, has the birth because we saw in that project that the topic of patterns is important. And why we talk about that? Well, we talk about the patterns in early childhood education. We consider that important because it is present in many knowledge domains, as is said in next generation science standards, is one of the practices that is recommended in those standards. They are part of other mathematic domains, as for example, the is shown in the web portal created by Douglas Clements and Julie Sarama about learning trajectories in different math domains. And they are cool and children enjoy them and learn from them. I think those are enough motivation to work in that topic. So that's why we are interested on that one, in that topic, and to follow those topics. We have some more general orientations. The one of our general orientations says that the children use concrete objects and actions but they are thinking using ideas. And this is important for us because we think that they are using objects and actions in order to understand, but they are also using ideas and thinking in some complex ways. As it says in one of our sources, that is the book, the different editions of the books, the Young Children Mathematics, the Young Child and Mathematics. This is one of our sources, and we take that main idea from that. And we will start in this moment. In this moment, I will stop my sharing by a moment, my screen sharing, just to ask you a question. You can answer by the chat. And that question is, where, what for you, what is the definition of pattern? What is pattern for you? You can please answer in the chat, and I will be reading just to get us started. If you can write there, and I'll be reading and reflecting about your answers about what do you understand by patterns. So it's open now for your writing. Stacy says, any shared sequence order of things. Daniela says it could be something that repeats several times, a repeated sequence, things that repeating shape or sequence. A pattern can repeat or grow or decrease. Foundation of math. They are different answers. They are different answers, and they are reaching the main point that we are talking about. And this is a good point, a good start point. Sorry, and we will continue with the presentation because we are talking about patterns, and patterns are about that effectively. But they have important elements that we have to know about them. Um, so we have in our we have different example of patterns. Example of patterns, like for example, time cycles are patterns. Time cycles like we are seeing here, like the seasons, like the day and night, like the patterns in our daily routine lives, like going to school, going out from school. And they are represented, for example, in the calendars, in some of those inventions. They are patterns in nature also, as we can see here. We can see here the different patterns about the birds when they are migrating and flying. Different in the shapes that, for example, some leaves or fruits in vegetables or in plants they have. Some patterns like the bees dance, some patterns in the dots that some cats have, for example, like the cheetahs, like the leopards, like the jaguars. So have some patterns. So, also they are patterns that are present in nature. Parents are present in arts also, because as we can see here, we have different parents in arts, as we see here in some of the digital created patterns in one side, in the other a pattern created in a famous drawing by Maurice Cornelis Escher also. And we have patterns also in math, in different math domains, for example, in geometry, in different series of numbers. We have in the different numeration system, in the numeracy system. We have them in different units that increase, for example, by six, like the time units. And in some math operations, like for example, in the multiplication and in addition also, we use patterns also. So as you said, many of you said, or you mentioned about the repetition of figures, the repetition, and this is a key feature that patterns have. And the definition, we took a definition taken from that portal of learning trajectories by Douglas Clements and Sorama, that they say that patterns are a sets of elements or units that repeats according to a rule, and they are part of mathematics that serves to all other parts of math. Even they say that maybe all mathematics is defined like a science of patterns, like a science of patterns in numbers and space, for example. So that's why they are important also. And they made an additional clarifying about the patterns, and they said that the pattern have different patterns, that the different units that that we need to define them as a pattern. They have a core unit, that is the unit that is the one that repeats many times, and the repetitions, the different repetitions with that core unit that create that pattern. We are here showing that in some simple way. That's AB pattern. That is a simple one, a simple pattern one. But we have also other more complex ones, because, for example, in some of your chats, you were saying, for example, that some of them increase or decrease, and they are some kind of complex patterns that are different from those more simple patterns. So we have those to just to have the explanation of the different aspects of the pattern. We have the core unit, that is the minimal unit that is repeating, and the repetitions, and of it is what that create the pattern. So that's why this aspect is important in order to understand what is the pattern. The patterns, as they say also in the same source, have an evolution. And it means that the people who is in understanding, the children who understand, begin to understand patterns, seem to follow a sequence, understanding them and learning about those patterns, have those names. And at that, and in this point, I want to stop sharing also. And I wanted to know if you can write also again in the chat, if you have tried to use patterns in your teaching, in some way in your classroom or with children. Have you used patterns, or have you tried to work with patterns? You can write if you have if you have done something of, or have some ideas about the how to work with patterns, and we can see how your ideas fit with with that idea of the evolution of patterns. They say, Stacy says, lining up and calendar. They say also simple dances. Yes. Calendar again. Transitions. They say it's also different color objects. Nice. Lots of games, following the patterns. What's next? Yes. Uh, creating the daily routine, they say. Distillation in science and art. Repeating the shapes with linear equations, they say. And over under moon phases. Nice. And if you see on you are saying have an important characteristics as you can see that they are from different ways of communication or different materials or different ways to access because they are objects, they are graphic, they are in time, they are kinesthetic also because you are saying about games, about the other routines, and you are saying even, for example, one that is not very usual, but it is it's important and it's nice to work on those, for example, like the moon phases and some of them. So they are different examples that you are giving and have those different characteristics because many of our examples, because it's easy to show it graphically, for example, are drawn, but there are also, for example, also in sounds like tum tum tam sounds, or some kinesthetic ones like repeating some sequence of movements, as you are saying. They are also some different kind of patterns. What is important in those patterns? In those patterns that are important, as we saw, the core unit and the sequence that make that repeats that core unit, and both of them make the pattern. So this is the main point that we have here. And sharing the screen again, my screen. We are here in the different in the evolution of patterns. If we can advance here, we have here. This is the sequence that we have about the field the how the patterns evolve in the comprehension of patterns evolve in children with their learning, and they have different phases, and they say it has like a graphic representation, and it says in the last column they say what children can in those phases. This is based strongly in that Clements and Sarama work, but they are showing how they change and how they become more complex in the children's activity. The first phase is about the intuitive feeling of patterns, where the children can feel and recognize regular repetitions. Is just how they feel. They feel the things that repeat. The rapid pattern recognition is about recognizing elements that form a pattern. The AB sequence that recognize elements that form a pattern and predicts what's next, the scenes of sequence. The pattern recognition with the same media is about recognizing sequence in the pattern and how they can repeat all the sequence, not just element or just trying to find one element, but to repeat the sequence and find the core unit to repeat that sequence. The next one is about the pattern translation and unit recognizing. That is when the children can recognize sequence, reproduce it, and identify core unit to reproduce it in new ways. And it means that they can not just imitate one sequence pattern, but they can create a new one based on a previous one, or make a new one, new media, following the pattern that was in another given one. And then the other phase, it says that the numeric and geometric spatial description of the pattern. And in that last phase, when they recognize sequence, core units, and can describe them in terms of repetitions or unit counting, or geometric or spatial sequence uses, it means that they can do all of those previous, but they can also talk and explain and flexible operate and what they are doing with those patterns. So this is a sequence of different phases that goes from maybe from the children when they are toddlers until their beginning of the elementary school, more or less. It usually happens, and they are showing how those parents get an evolution. In the first one is about the intuitive feelings, that is about repetition and anticipation. Some of you said about the repetition and anticipation that is important, about the rhythms in songs, for example, that you said also, and about the different stability in routines. And they have, for example, feelings and sense of regularity and stability in some actions, since the children, since they are babies, when they are from very early age, they have the sensitivity to feel the patterns or the regular forms. And this is the first stage or the first phase that in that recognizing of patterns. In that part is also important to work in the music, in the rhythm, in the movements, because they have also working that sensitivity about the patterns. The next one we saw is when they can see and recognize what is a pattern when they were asked by adults, and they demand them rapid recognition of the pattern shapes, like the visual input or other kind of inputs. So they can, for example, when if you see that there is something, there is a pattern, there is something repeated, there is something like a shape, for example, in those ones, they can see, for example, that there is the pattern, repeated pattern in a shirt, in a t-shirt, in a drawing, or in the cats, as we are seeing here in the examples, or just in simple figures, for example, tiles in the games, and they can recognize that they have repeated forms that forms the patterns. Um, in the AB or the core unit and the missing elements, they can have another additional step, that is that recognize what can follow in a pattern. And for example, here we can see that we have a yellow, green, green, yellow, green, and what's next? And they can say that the next would be green, because we are following that sequence, and they can understand that we have that sequence, and the next element would be, and the next that complete that sequence, that in that case is the green. The next is the pattern recognition with the same media. And in that one, they can repeat the complete core unit or sequence of a core unit is to easily do a pattern. And in that one, they can recognize and reproduce patterns using the same media. They cannot just say what is the next one, but they can also reproduce and create by themselves the pattern based on another one that we show them. And they can do, for example, not just one unit or two units, but maybe repeated units that make the pattern. And that's what they can do in this moment. They can follow all the not just one, but all the sequence of the pattern that could follow. They have they in the next one, they have the pattern translation and unit recognizing, and in that one they can do all the previous ones, but they can also here reproduce the pattern in another color, for example, because they can recognize what's the unit, and they can have some more abstract idea about what is the unit, and can reproduce in another media, for example. They can see that we have a sequence that is yellow, green, green, yellow, green, green, and they can recognize and make the same one, but with blue, red, red, blue, red, red. And this is and they can it means that they can identify the core unit and translate into that new media to create the new patterns. And they can operate with the notion of the pattern that is not linked just to one physical or from particular physical objects. They can translate to other physical objects trying to recreate those patterns. And in the other one that is one of the most advanced and maybe more usual, for example, in the children when they are already in elementary school, is the creation of the patterns, seeing the adult creating and growing a patterns, and this and not just creating but describing how they can do and how they can make those patterns following the same idea or the same media or different media, but creating they can what they essentially can is describe that pattern numerically and represent their construction using and expressing numerical and spatial elements and units. We have here, for example, those kind of examples that some examples that the kinds of things that they say that, for example, we made this one yellow square and two green squares, and we repeat it. This is made with one figure in one color and two in another color, repeating it. This pattern is made with one figure in one color and two in another color, repeating it in a straight line. If you can see, they mention numbers that how they are repeating the numbers of repetitions that they are using, and they are, for example, referring to shapes because they mention, for example, straight line, and this is for what they refer or when they are talking when they can describe the pattern and talk about that pattern in numerical or geometrical terms in order to reproduce that. Those are the main. This is the main sequence for the patterns. In here in the presentation, we made that describing for each one of those phases, but as we saw at the other part at the beginning of that section, we made also in a slide when you can see all of them in the same slide. So it's an easy guide to see all the complete sequence that the children are probably following in their evolution of their comprehension and understanding of patterns. And we have also some exercise. Those exercises are suggestions about some activities. You mentioned different activities in our chats. And here are another examples of those exercises that we can use following the ideas that we talk about in the sequence of the evolution of that comprehension or understanding of patterns. One of those exercises is that one. For example, we can say to the children, if we put these faces in that way, what comes next? If you see, it demands discovering what follows in a pattern. It's in the elementary, maybe in the most elementary stage. For example, it would be useful to work with children who are younger or who are just beginning or just begin their opportunities to learn about patterns, so that we can begin with those simple ones. It is important to have variety because if we use maybe just one kind of units on what kind of media, they can grasp the wrong idea that the patterns are just with tiles or just with faces or just with numbers. So we need to change those different media, and it's better if we have, as you said in some of your chat interventions, for example, to say to graphic elements, but also sound elements and maybe also kinesthetic elements. So they can grasp better the idea that we can use patterns in different activities. So this is important in that activity one. We have as a suggestion also that this second activity that we can use when they advance a little bit more, they can recognize, they can reproduce what follows in a sequence. We can advance to the next stage. In the next stage, we can say, if we put these squares in that way, how can we do a pattern like this? And they can try to reproduce, they can try to do something similar to what we are doing and trying to reproduce all that in the same way, where sometimes they got engaged when they have Legos or they have some of that kind of games, and we can make a sequence in them, and they try to make the sequence and get the longer possible. And this is when they are, for example, they are a little bit more advanced. They have the basic comprehension of what is pattern about, and they can try to make more complex patterns in that like intermediate level, we can say. And in the activity three, we have this one where we can say to them, can we do this pattern using squares with other colors? Or if we count like this, can we tell me other numbers that follow after those? If you see in that one, is that the thing reaching one of the more complex levels, because they have to reproduce the pattern but using another media, and it demands to them discovering what is the core unit to reproduce the pattern, and to have that in their to keep that to remember that and reproduce that in another media, but trying to keep that core unit and sequence, but in that other media. And this is for more those that have a good dominion of the intermediate and can advance to the more advanced level, and maybe they can try we can use that one to them when they are reaching the good level in that one, ask them to say what we are, how we are doing that repetition, what is the try to describe that pattern as we see in the most advanced sequence. And this is the point about those patterns that we are having here. Um, this is the last one that we have. Those are activities that can be done with children. Those activity one, two, and three that we were describing. As we said, because it's easier with the graphic presentation to show them in graphic units, but we can do it in some other units like sound, like kinesthetic, like in movements, as you say in your examples. And this is the other one that we can use. And I think like take away in some way from that presentation, that presentation, as I understand, will be shared with you, with all that have been here and those who have registered. And we have here, for example, the sequence of the evolution of patterns that can guide us in order to see in which of those levels the children are, in order to think in our activities. And we have also the the definition here that we have about the core unit and the repetitions. That is also important in order to understand the patterns. And the other one that we can have here are those exercises that are examples or just examples when we can have a start with that work in patterns when we have the children at different levels. That one in that way that we call activity one, with the most with days that are just beginning. Other one that when they already begin, they are initiated, but we can demand them a little bit more in a more complex way, to a more intermediate level. And that activity three, that is for those that are more advanced and that will begin to get more abstract idea about what is the pattern. And those are the main ideas that we share today with you in that presentation. As I told to you, this is part of we share, for example, with the people who work in libraries, because this is an area in general. Mathematics is an area that generally scares them because they are not used to that kind of areas in libraries sometimes. But for example, trying to show that kind of activities in a friendly way to them, they can see that the math is doable, and they can do some of those activities in libraries. And this is what we are working in our research project that is coordinated by Dr. Alisa Langi in our university, in East Tennessee State University. And it has as a co-researcher, main co-research, one professor, the Dr. Bharat Mehra from the University of Alabama, that is more in the field of library and information sciences. And we are working together trying to get those that maybe are more known in the field of early childhood educators and mathematic educators or STEM education, more to the people that, for example, the people who work in the libraries staff that are sometimes less familiar with those topics. And we are here introducing them in the way that we can think about those kind of patterns, and how we can think about those topics for them, and how they can do it with in early math, and with diverse families, and with the different in different contexts. Because, for example, we emphasize with them that we can do that using, for example, traditional garments, traditional figures that use in the different cultures that the families come from. And those kind of things we can use in order to advance in those kind of activities, the ways that they use to count different elements and things like those. And those are part of the kind of traditional art that sometimes that some of those cultures, the traditional cultures, have also. And they are that sometimes are part of the families of the children. And we try to use those kind of family fonts, or to suggest that kind of family fonts to integrate on those kind of knowledge about patterns also. So this is the the the, the material that we had today to share with you. This is the information about me and my contact information. And as we are sharing, this presentation is available to share with you, as well as the video of this presentation. We can then you can access to our project, because here there, if you saw that they have a QR code when you can access and ask interest, or see the material. And this is the point where we are. And just wanted to say thank you to you in order to stop here in this moment. Maybe if we have, I don't know if we have